We're here to talk about their fantastic book, which, if you're anything to do with the Beam, Erlang, Elixir, Gleam, whatever, it's a must read. And in fact, I would say it's actually a must read if you deploy software anywhere. So with that, welcome. Good to see you.
Thank you. Nice to see you. Thanks for having us on.
Yeah.
Oh, totally my pleasure. At the start of your book, you say that by the end of the book, you'll have a multi-node Docker swarm that is distributed across multiple availability zones in AWS and that auto-scales according to the average CPU usage of the service hosting your application. You forget to say you will also know how to fly. That sounds like an incredibly ambitious target for a book. Is that really achievable?
Yeah, I mean, we cover a lot in the book. And yeah, it's very dense content-wise, but we hope that it will be kind of digestible and won't go too quickly over important things, or equally doesn't go into too much detail into things that are maybe more trivial. So we've tried to give a good introduction to all of these technologies for people that don't understand anything and have never touched Docker, for example, before. So hopefully they can get a good understanding of what it is, how to use it. And yeah, so it's a long journey we go throughout the book. But
we also built a Phoenix Live View application which allows you to display to visualize all this infrastructure and also stress the cluster. So normally the issues with when you are trying to work with infrastructure is that everything is a bit like abstract, no? You work from the terminal and things like that, but in this case we tried to put a lot of love, so we created this application that allows you to visualize the different nodes in which availability zones they are deployed. It allows you to see the CPU usage and then it allows you also to stress the cluster and see the different auto-scaling activities that are happening, which is, I mean, when we were writing this application, it was, even us were learning stuff, no? Because in order to be able to display it in a visual way that is understandable, we all learn on the process.
I have to say, when I read chapter 2, Terraform, I thought, wow. I mean, most people would start, gently and work their way up, but you guys just go for it. And I have to say, I personally learned a lot from that. I mean, was it hard to work out what level to write this book at?
yes and no. I mean, Josep has a lot more experience in the technology kind of field than I do. So we're a good pairing in that sense, that if we came up with something and I didn't fully understand it from reading it, then we decided, right, no, we need to go into more detail on this because it's not as obvious. And a lot of the time when you're talking to developers, it's very easy for them to say something that for them comes really naturally, and because they've been studying or working with the technology for so long, something might be so kind of easy to them, but then you say it to somebody else that has no idea what you're talking about, and that other person will think, but what does that mean? Or you've said that, and why have you said that? Or why is that important? Or why is that not important? So it was, in that sense, it was quite easy because there was kind of this difference in level between him and I. It was quite easy to then explain things in a way that everybody would understand.
Yeah.
So that if you do have a lot of knowledge, then it would be kind of reaffirming what you already know. But if you don't know anything, then it would be a good introduction.
Yeah, I think I fall into the don't know anything class, and I found it actually quite compelling to read what you were writing, and it kind of inspired me to think a bit about how I was doing just day-to-day stuff, not just Elixir or Erlang, but just general deployments. So yeah, back in the good old days of telephone exchanges, a deployment basically meant creating a release of your application and then somehow copying it to a server. Why can't we just keep doing that?
I think it's because we need to fail fast. The problem with this process that you described is that you end up fearing deploying, no? Because I mean, you are not used to do it. And the idea that we also try to transmit with the book is that we try to follow this Kaizen principle. So you try to submit as much as possible, something small, and then you test it, no? So then everyone has this sense of ownership, no? The problem is if someone, this kind of deployment that you're talking about, it might be also not shared. Maybe there's someone that deploys, no? But this is not a role that is going to be shared. If you submit a pull request to the main branch and it's automatically deployed, everyone knows that it's going to be deployed. So everyone is going to be more careful, no? So going back to the pragmatic programmer, no, with the abandoned car or the abandoned house, no.
So you're looking at repeatability and you're looking at shareability, but also you're looking at a process of gradually adding to the process as you go along, which I guess means you've got to be able to repeat the early steps absolutely the same every time.
Mm-hmm. Yeah, I mean, we kind of think, or something that we try to get across is that perfection doesn't exist. And so if you're trying to write a perfect feature and you keep it in your laptop, in your editor for so long, you'll never push it out because this won't be right, or this won't be right, or this doesn't happen, or whatever. Or I could write that even in a cleaner way, like that needs to be refactored or something like that. So we're trying to get across that no, you shouldn't do that. You should try and be more proactive and be more, as Josep said, pushing smaller features more often rather than doing a massive pull request that's like 300 files long, because I mean, having to look at that would suck.
You aim small, you fail small, no? Obviously, there are always going to be big pull requests, no? If you need to land a big feature, that's going to happen, but at least the context is going to be specific to that feature, no? But yeah, it's lovely when we have a pull request that is really, really small.
You make the point that DevOps, which is kind of what we're talking about here, has become more just operations and less development. And you want to put the developer back into DevOps. How does that manifest itself in the book?
I mean, the book in general is about teaching a more developer type person how to, it's more of an introduction into the Opsy world. So the whole idea is that they don't just kind of sit in what they already know. So we repeat the phrase, throwing something over the fence, or the throw over the fence culture, which for us is somebody says, no, I'm not going to do that because that's not my job. I'm a back-end developer, so I'm not going to, I don't know, do a front-end feature. Or I'm a front-end developer, so equally I'm not going to do a back-end feature. So we wanted to try and get a more dev person in. We wanted to introduce them into the Opsy world so that they understood what goes into to deploying an application, rather than just focusing on their single domain.
Exactly. Yeah. And then you have healthier teams and there's more love in the environment and everything, because knowledge is shared, the problems are shared, no? And we all take care of each other, and also everyone can go on holiday because everyone can do something, no? Because we all have suffered this issue of getting to a point where you want to keep on moving forward, but you can't because there's something that is blocking you. And the idea is that we try to remove all the blockers, no? And that's the only way to do that is by sharing the knowledge, but not having single responsibilities, but not having the keys of the deployment, for example, or things like that, no?
Right. Also, it means that as an individual, you are no longer tied to doing one particular thing. So that, if you happen to be the only person that knows how to do deployments, then you're kind of stuck for the rest of the project doing deployments, whereas if everyone can do them, it just gets shared around.
And also, there are no excuses, no? So you cannot say that your cat ate your code base, no?
But also, yeah, but not just no excuses. There's also less to be excused. It no longer is a personal thing. If it's not like, you know, Dave is responsible for deployments. Deployment failed, it's Dave's fault. But if the team is responsible for deployments and it fails, then we fix it.
Yeah, exactly. I mean,
Exactly.
one of the things that sharing all of the responsibilities, it creates a lot more empathy across the team. And I mean, it makes teams work, I think, better and more efficiently. Um, and you don't have so much like personal, um, I don't know how to say,
Friction.
friction. Yeah, good word.
So is this something that uh, you are teaching other people to do, or is this something that you do in your own company? How does that work?
We are trying. Yeah, we are trying. The first thing that we saw this, I mean, we fell in love in a company long time ago, six years ago, and the only company that I've been seeing following all these practices was this one. And everyone was happy. Well, I don't know if all the teams were happy, but at least in the tech team, everyone was happy. There was a sense of shared ownership, love, empathy, and so on. And we're following these practices. Then, wherever I've been working, I've been trying to apply these practices, but in corporate is, or I would say in the bigger companies or the companies that already have lots of processes, infrastructure in place, and things like that, it's hard to apply these practices. But yeah, currently we are working with a customer who is in the States, and I think we've done a good job. I mean, we dockerized everything. We implemented continuous delivery, and yeah, even more stuff, interesting stuff with Packer. And I think we have already added a lot of value. But yeah, we are trying to do that. It's tedious sometimes because the problem when you do these things is that you take the power of the people that are in charge of deployment and things like that. No, so because you are delegating the power to everyone. No, because you are automating the process. And sometimes it's this because there's people that don't understand this or see that as a threat or as losing power and things like that. But we are trying with all our hearts, no? Yeah, and I think the stakeholders already see the benefits. So yeah,
I can see that. Yeah, I could definitely see the idea of it being threatening, that
yeah,
you're democratizing the whole process. But
yeah.
yeah, I would imagine also though from a company's point of view, that must be quite a powerful um, benefit that you can basically sell to them, that you can make their process more general, more easy to use.
Well, I also think it makes you be able to ship features a lot faster if you do that, or even if new people come in and if you've, let's say in the example of this customer, if you've Dockerized everything, people can really quickly spin up the app, so there's no kind of blockers to entry for anything. And it means that everybody can work faster. Or if you have a CI/CD pipeline, it means you can then deploy faster. And it's a lot more obvious what the deployment steps are if they're all written down and they're all in a pipeline, rather than someone having all of that knowledge in their head and only them knowing how to do it. If you see it and it's written down, then it's a lot more obvious and you can fix it a lot quicker.
That is fantastic what you just said because by implementing this, in the end, what we are achieving is to let the code base be the source of truth of everything. No, if you have continuous delivery, you don't need to ask anyone how the application is deployed. But you can just go to the GitHub workflow and then you can see how it's deployed. No.
That's what I like about that, is that you actually have uh, the documentation is the code. It's not like a separate 16-step thing that you have to follow. So in my personal experience, when I've done this kind of thing, I've not done it as well as you, and I'm not doing it using the same technologies. But I often find myself uh, procrastinating, maybe, by playing with the deployment technology as opposed to actually delivering the app. I mean, is that something that you see, that you kind of get into fiddling around on the actual deployment and not focusing on the application?
That's the problem when you like everything, that you might get distracted and lose focus. There was a moment with this customer I was only thinking in infrastructure, but then there was a moment that the stakeholder said, okay, it's done, it's working already. I kept on pushing for a little bit because there was still one thing that we needed to do, but then we focused on the application, and we love the application layer, and it's just a matter of switch now. The infrastructure is in a maintenance mode, and whenever there's something that maybe requires some attention, we switch, but it's more like not on a daily basis.
Yeah, I think that can happen when you get distracted or you're pulled between both when you're setting up the initial infrastructure. So, I mean, it took quite a while to set up this initial infrastructure for this particular customer, and to Dockerize everything, or to get it into a state where you could then make these Kaizen principle changes, so these small incremental changes, or even then to deploy new features quickly. So I think when you're maybe implementing that or setting up the groundwork or the foundations of the infrastructure, I think that can happen. But hopefully once that's all in place, the changes or the updates you'll then need to make to that should be fairly minimal. So it does leave you lots of more time to focus on the application.
Yes.
So what you're basically saying is you're more disciplined than I am, which is true.
Maybe.
So could you, in just a few minutes, just talk through the actual process that you're talking about here of you come into a situation and you know that you're going to be writing a medium scale application. So what are the steps that you go through to get that all set up?
We try to, I think we are different because we try to have empathy with the people that is part of the team, no? Because normally the problem with operations is that they would tell you what to do and how it needs to be done, no? And normally they say, no, it's Kubernetes. That's it, no? In this case, the reason why we decided to use Swarm was because we were trying to connect with people, no? We were trying to say, okay, if I'm a developer and we want them to jump over the fence, we want them to use the tools that they are used to. And if you are a developer, normally you use Docker Compose to set up your Docker environment, no? Your local environment. So that's it, no? I mean, the first thing that we do is try to think about the people that are going to be this infrastructure is going to be used by, and then we decide accordingly, no? For example, with this customer, we also decided to use Docker Compose, not Swarm, but Docker Compose. And the reason why we did this is because we wanted to enable anyone on the team to be able to deploy easily, no? So all of these things we try to think about. It's not only, okay, let's find a solution. We need to achieve the objectives that we talk about in the book, which is continuous delivery and so on, but also we want to be able to participate of that process.
And also have the same tools be used for development and deployment, presumably.
Yeah, that's one of the main things. I mean, that's one of the big benefits of that we saw to Docker Swarm, which is why we decided to conclude that in the book. Because you can use you use the same Docker Compose file for development and then production, deploying to production. And I mean, it's the same with this customer, even where we don't use Docker Swarm. We have a Docker Compose in production and in development.
So you're using the same tools in development and in production. Do you ever get into the situation, though, where you find things that work in development and not in production, or is that now a thing of the past?
I mean, hopefully it will be a thing of the past. One of the big things that we talk about is environment integrity, which is what you're talking about, using the same tools for development and production. So hopefully the idea is that you can replicate all production scenarios in development, so you don't come into a scenario or a situation where there's a bug, let's say, in production, and you can't reproduce it locally. So hopefully that will be a thing of the past, and it won't be something that people will have to come across.
One of the downsides I've come across with the idea of, I guess, environmental integrity is that it's all too easy to lock yourself into particular versions of libraries and everything else, and it works and it keeps working until 10 years later, where you discover that library no longer works on a modern architecture or something like that. How do you build in time to keep refreshing that environment to make sure that it keeps up to date?
Well, there are tools we use. I don't remember the name. Renovot. We used to do that, but now I'm confused because there's a new one called Renovate. But this is a tool that you add it a workflow. You add it. I don't know if it's a workflow or you install it as an application in your GitHub repository. I suppose it will work with other Git providers. But it regularly checks your dependencies and things like that, and invites you or submits pull requests automatically to try to update those dependencies. And it works on everything. Not only helps you update your mix X for if you are working on an Elixir application, but it also looks inside the Docker files, looks inside in the GitHub actions. So if you are using, for example, Erlef to set up Beam, it will look at the version of the GitHub action and update it and submit a pull request. So yeah, in the end, you want to do exactly the same thing when you enable continuous delivery. You want to delegate that thing to an automation, because if you delegate it to a human, eventually that human is going to forget, is going to become lazy, or I don't know, it's going to just make human mistakes. So yeah.
And because it's part of the CI pipeline, that if you do update something and it breaks the app, you'll learn about it because of the testing.
Exactly.
Everyone will learn about it.
Everyone will learn about it, yes. Yeah. And do you guarantee that if you start using these practices, you'll find someone to fall in love with?
Yes.
Yeah, that's what we are trying to achieve.
That should be our marketing tagline.
Yeah, everyone should be in love with each other. Yeah.
But no, I'm sure that on a less frivolous note, I think the idea of automating away all of these friction points, can only make a team a happier place to be.
Yeah, and we have applied those practices also to the book writing process, no?
Mm-hmm. Yeah, I mean, we had our own CDI pipeline for the book, for each chapter, checking all the code in each chapter to make sure it works.
Yeah. Yeah. So we actually, yeah, the book building toolchain, we zip it and then cipher it, and then we upload it with Git big files, and then with our environment is built with Nix, and we start exactly the same Nix environment in the GitHub action, and then we build the book as we would do locally. We have like a CI workflow for each of the chapters, no?
Mm-hmm.
Yeah, we even wanted to reproduce the whole infrastructure that was being built in each of the chapters, but we said, okay, let's do the minimum at least, which is, for example, if we have a Terraform module, let's try to validate, check the format, and this and try to at least plan the Terraform, but not apply it, no?
Mm-hmm. Yeah.
But yeah, and this code base also is part of the snippets that we include in the book, so the book is tested, no? So we are confident.
Yes, hopefully confident.
Happy.
Hopefully confident. I like that.
And we still love each other, no?
Yes.
Yeah, because I mean,
see, that is an achievement actually. Writing a book as a couple can be quite stressful.
Not if you have a CI pipeline.
Exactly. So
I mean, the writing process was interesting. I feel like at least once during each chapter, we'd have an argument of blah 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 blah.
No. It wasn't like that. It was more like that.
A bit more like that. But no, it's been good. It's been great. It's been a nice experience for us, obviously, to go through together, and it's been nice because we obviously communicate very well, and we know there's no egos, there's nothing like that, so we can say something without the fear of somebody else taking it personally or taking it badly, and everything. Any comments are always constructive, and so there's no dynamics like that. And yeah, I mean, it's been great. We've, I think, learned a lot from each other throughout the process, which has been good.
Yeah, I think it's a perfect test to actually check if you love each other. Yeah.
Well, listen, you guys are absolutely fantastic to chat with. And like I say, I think this book is it's a significant book. I think it actually is going to help a lot of people, and not just in the Beam community. I think a lot of what you talk about is applicable universally.
Mm-hmm.
So very, very nice to chat with you. Anything final to say before we wrap up?
Yeah, I think you are right. I think you are right, and this can be useful for more people, not only people that are interested in the Beam. And we wanted from the very beginning to reach as more audience as possible, because all these concepts can be applied to any technology. And in fact, when we choose the reviewers, we try to pick people that were only from the operation world also, so they could actually validate this. And they were able to go through the book without having any knowledge of the Beam. So, yeah. And also, thank you for having us, Dave. It's been an absolute pleasure to talk with you. So, thank you.